Okay, so today we're going to look at introduction to routing. We're going to understand what's a router, how a router performs, and we're going to look at the routing table. We're going to look at several ports in a router. Then we're going to look at the basic router configuration. We're going to look at how to configure the router remotely using Telnet or SSH, and we're going to learn how a router help us to connect multiple networks. So the first thing is routing basics, and although I didn't send these notes, but I'll send them immediately after this class. So routing basics, sorry routing basics. So introduction to a router. What's a router? Functions of a router, how a router works, various ports in a router, memory types in a router. A router. So we learned that a router is just a device that operates at a network layer of a SIM module. This is very important. Network layer of a SIM module is a layer 3. Layer 3. So layer 3 of a SIM module, which is a network layer, that's where a router is found, and that's where a router operates. So basically, a router operates to connect multiple networks, and we see that a router uses IP address to send and receive data. So the concept of IP address is very, very important in a router. A router uses IP address to send and receive data. It performs packet directing function in the network. For example, in this topology, in the below topology, when this PC sends a message to this PC, the message will get to this router first, and this router will know how to direct the packet to this PC. Maybe it will take this downer part or the direct part. Function of a router. It joins multiple networks. For example, when you have multiple networks on a switch, we just have a normal switch, and just for a demo, you just have a normal switch and two computers. And these computers belong to different networks. For example, this one is just a minute. For example, this one is 192.168.1.10. Then leave it there. Then I copy this. I come here, the first thing I want to put them in the same network. Remember, the first one was 1.10, this one is 1.20. Yes, so same network, they will communicate. I will try to ping, they will communicate. But when we try to change them so that they belong to different network, I just go here and change 2. So
So
yes,
that one is that means same network.
Yes. We will going to learn this when I begin about subnetting, so that we can learn how to identify whether the computers are in the same network or not. We're going to use a concept of subnet mask. So although they have the same subnet mask, but 192.168.2.20, but that one was 1.20. So that's different networks. Although we're going to learn much about them when we begin subnetting. I click here again and try to ping. They will not communicate now because they are in different networks. You know, in a company, we might have different subnets. So if you don't, if you only have a switch, how will these subnets communicate? And that's why we need a concept of a router. So a router joins multiple networks and they will communicate. A router assigns IP address to end devices. In the coming classes, we're going to learn a concept that is called DHCP server. DHCP server is a concept that allows host devices to have dynamic IP address configuration. For example, when you go to your, for example, even here, there in your house, you connect your Wi-Fi and your phone will receive an IP address from a router for it to connect. So that's a function of a router. Also, a router selects best path when there's multiple links to the destination. For example, here in the topology, this PC1 wants to communicate with PC2, and the first line of contact is this router. So when the packet reaches this router has two paths to reach to PC2. The first path is through this router, then to this router. The second path is just direct to this router. So this router here will select the best path. The best path basically means a path with low cost. You know, you have to minimize expenses. A path that will minimize the expenses in terms of cost. So it will select the best path in terms of cost to reach PC2. Okay, so those are the functions of a router. I'll send these notes. Our router works. We realize that when a packet reaches a router, the router examines the destination IP address of the packet. For example, when I go back here, when this PC sends a message to this PC, the message will first get to this router, and this router will examine the destination IP address of the packet, and this router will find that the destination is this PC. Alright, so after the router has examined the destination IP address of the packet, the router will make the routing decision accordingly. So we see that routers use routing tables to determine how which interfaces the packet will be sent. For example, here, after this router has examined the packet and it finds out that the packet belongs to this PC, and this router here has two paths to reach to this PC, the router here will make the decision accordingly to determine which interface to send the packet through. Maybe it can send through this interface or through this interface. Okay. And we see that a router uses routing table. A routing table is basically an entry that consists of the destination. I mean the destination, the destination host, the subnet mask, and the interface through which that host is connected. For example, a routing table lists all networks for which routers are known. Each router's routing table is unique and is stored in the RAM of the device. So the routing table. A routing table is a set of rules, often viewed in table format, that is used to determine where packet traveling over an internet protocol network will be directed. So basically we just use routing table to know where the packet will be directed. So for example, when a router receives a packet and it checks on the routing table to know where to forward that packet. Maybe the destination has already been installed in the routing table. So depending on the destination IP address of that packet, the router will know whether to add it into its routing table or to just forward it in case it's already existing. So we find that all IP enabled devices, including routers, switches, uses a routing table. Okay, so for example, in this router here, we see that this router is connected to 3 PCs, 3 computers, and each computer has a specific MAC address, a subnet mask, and it's connected to different ports. For example, this is the routing table. We see that the first computer may be having this IP address, subnet mask, and is connected to this interface of the router. The second PC is the same, and the third PC is the same. So what's important here is just the concept of routing table. You must know that a router uses a routing table to make decisions on how to direct traffic. When the packet destination is already on the routing table, then the router will definitely knows how to forward that traffic. But when the destination is not in the routing table, the router will install the destination in the routing table, so that when the next packet comes, the router will just know that there was a packet that passes through this destination. Okay. So various ports in a router. Basically, we have a lot of ports in a router. We have a lot of ports in a router. For example, we have serial ports, we have fast Ethernet ports, we have console ports, we have auxiliary ports, we have power switch, the power button, and we have the power port, the power cord connection. So you just connect your adapter here, your power cable here, and you power on the router. Use this button to power on the router. So the Ethernet ports are used to connect devices like switches, PCs, servers, etc. Then you have console port. Well, as you can remember, console port is used for the local configuration, line console 0. So you remember that line console 0 that we used there was actually used to configure the device locally. You just plug in, I was doing this yesterday, you just plug in either console cable with the Ethernet on the one side and maybe USB on the other side. So you plug in the Ethernet on this port, the Ethernet side on this port, and the other side, which is USB, you plug into your computer, and you use some software to obtain the router's interface from your PC. So console 0 is very, very important in any device, because it's used to manage that device locally, physically. When you're there, just plug in a port, just plug in a cable on this side, the other side on your PC, and you configure it. Alright, auxiliary ports. Auxiliary port basically is used to connect to modem for remote configuration. For example, this is the port that we're going to connect to internet modem. So when you connect modem here, then the device is online and we can access internet. And we also realized that we were configuring 2 lines. The first line that we were configuring was line console, then line VTY. I've said that line console is used for physical local configuration. When you are there close to the device, just plug in a cable and you do the configuration. But line VTY is used for remote configuration when you are away from the device. For example, you are in your office and you want to configure a device that is located in the server room. So what do? You assign that device an IP address and you use line VTY. So auxiliary port is used to connect to modem, and through the internet access we shall achieve our remote configuration through the device. Finally, we have serial ports. Serial ports are used to connect different networks. For example, we can use this serial port to connect to other router, this one to connect to the other router. So that's how it's done. Then the power switch, you just know to turn the device on, off. This one you just connect the power cable so that the device can receive power. Okay. Memory types in a router. This is very very important, you know, and most in the most of CCNA exam they normally ask this question: memory types in in a router. The first memory type in a router is called RAM, and RAM is used to the content of RAM. We just have running configuration, we have routing table, ARP cache, and working memory. For example, when you say do show run, then the do show run command is going to trigger running configuration, and the running configuration are stored in the RAM memory. So you know, when we power off our device, the running configuration will be lost because they are volatile. When we just power off this device, all the RAM content will be lost because they are volatile. Okay. Then the next thing we have ROM. ROM is used to the content of ROM is just like power on self-test software. We have bootstrap software, which is very very important. We have ROM monitor mode, locate and load iOS. So it's a ROM that will locate and load iOS, and it's non-volatile. Whether we power the device off or on, whether we power the device on, it will not.
Okay.
Yes.
One question: what the difference like a volatile and non-volatile?
Well, non-volatile basically means, volatile basically means that in terms of memory, in terms of power, when the device is on, then the configuration that we are doing will be lost. Or how can I say that? Do you know RAM? Just the normal RAM that we use in our PC. We say that RAM is volatile because the memory content of RAM, when we power off the device, it will be lost. But you know, the ROM, the hard disk, is non-volatile. Whether we power off the device or power on, whatever we stored there will be still there. We'll just find it there. So for just a quick understanding, I'll just open Google. Volatile and non-volatile memory. So I'll just go to Wikipedia. Okay, so Wikipedia just says that non-volatile memory is a type of computer memory that retains stored configuration even after we've removed power. Whether we power it on or off, the device, the content of the memory will be still there. But volatile memory needs constant power in order to retain the data. So that's the difference. The issue is power, just power. In non-volatile, when you remove power, the content will still remain. But volatile, when you remove power, you will lose everything. So that's why we say that RAM is a volatile memory. But ROM, NVRAM, hard disk, etc., for example, flash disk, your CD card, memory card, they are non-volatile, because when you store music there and you power off the phone, you power off the computer, when you turn on the computer again, you still find your music on the hard disk, on the flash disk. So it's non-volatile. But RAM is volatile, because whenever I power off this laptop here, all the RAM content that is already stored, the cache data that is stored in the RAM, will be lost. Okay. So the next thing is flash. Flash memory stores iOS. iOS is just the Internet operating system. So the Cisco operating system that is running on Packet Tracer is stored in flash, and it's also stored additional configuration files, additional iOS images, and we just use show flash to see the content. Then finally, which is very important in our configuration, because basically we normally interact with RAM and NVRAM. ROM and flash are quite much deeper, and we don't normally interact with them mostly. So we normally say do show running configuration, do show startup configuration. So we normally run with we normally operate with RAM, ROM. So NVRAM contains running configuration and configuration registers. So NVRAM also is a non-volatile memory. Non-volatile. Whenever you power off the device, you will still find the content of the configuration that you are doing. So you just have to know the different types of memory in a router and what they store and how to verify them. For example, flash, you just say show flash, and NVRAM you just say show startup configuration, show version. For RAM, just say show ARP, show IP route, show running config, show memory, and that's all. All right. Okay. All right. So I think that's all about the basic
routing.
Yes, the routing basics. So basically, we just need to go to basic router configuration, which is very important. Basic router configuration, we will learn this also under the basic. So basic router configuration, although we did this in the switch, but we need to do it here again because we started routing and we need to begin from a very simple, a very beginner level as we progress. So among the things that we're going to configure includes host names, line console, line VTY, enable password, banner messages, encrypting the password, disable IP domain lookup, saving configuration, and displaying and running saved and running configuration. And before this, just a minute, there are things that we need to include. There. Okay, so we are going to configure a lot of basic configurations on the router. The first thing we're going to do host names. The second thing we're going to do line console. Under line console, we're going to configure password. We're going to configure exec timeout. We're going to configure login synchronous, line VTY, password, exec timeout, and login synchronous. And I want you to understand these two lines and why we are configuring them. I said that line console is used for local configuration, the physical one. For management, you just plug in a console cable on the device, then on this other side you plug into your computer and configure the device. But for line VTY, it's used for remote configuration. For example, you want to configure a switch that is in the server room, but you don't want to go to the server room physically. You use line VTY. So you must configure password, exec timeout, and login synchronous. Yeah. The next thing, enable password. Enable password. This is the basic level of security in every device. Banner messages to be.
For me, I always thought we do enable password before line console and line VTY.
Well, it doesn't matter. So you can
Doesn't matter?
Yes, it doesn't matter. So what must follows. Sorry. What must come first before other is configured is this one, because this one are included inside this one. So this one must be there first so that to configure this one. But it doesn't matter. You can start with any that you like, any of these. Okay. Then banner messages, we need to encrypt all the password. We need to disable IP domain lookup, prevent brute force attack, and login delay. Suppose you try to log into a switch and you forget password, that switch should try to relay you, because probably you are an attacker, and if you are granted access faster, you probably might guess the password. So that's why you should be delayed for quite some time, and that's also a level of security, And also we should learn how to save the configuration, display a saved and running configuration. Remember, running configuration, we say that they are stored in RAM, running configuration. But saved configuration are startup configuration. They are stored in NVRAM, startup configuration. So that's why I told you that we normally interact much with RAM and NVRAM. RAM's running configuration, NVRAM startup configuration. Okay. So without any further ado, I'll proceed to configure basic settings on a router.
So that it prevents brute force attack.
So brute force attack is a kind of you try to guess password until you find it. Yeah, for example, when I know your name and your birth, people normally make their birthday dates as their password. So for example, when I know your name, I know your birthday name, I can try to log into your Facebook. For example, I try to put your password as your birth date, your name, your phone number, your ID number, things like that. So those are called brute force attack. You try to guess password until you find it. So we want to disable kind of scenario in a router. Alright, so I'll go directly to our packet tracer. I just try to put it down here. So we've started using a router. And whenever you use a router, a switch should be there and a computer. And in this demo, we'll be using a certain type of a router. This one. 2911 router as per now. There will reach a time when we'll be using this router, 2811 router. But as per now, we'll be using 2911 router. Just click it and I place it somewhere there. And just connect it. I just want to connect it to this switch. Okay. Alright. So when I go back here, the first thing was how to connect a router to PC using console cable and do basic iOS command or configuration. We first need to connect the router to PC using this cable. So this is the console cable that I'm talking about. Remember, this RJ45 side, the Ethernet side, goes to your PC, and this VGA side goes to the router. So let's do that very fast and start configuring the router. We can do through the CLI, the router CLI. We just click on the router and come to CLI and do the configuration, or we just assume that this is a physical device and now we need to include our PC here or a laptop and connect a console cable. This is the console cable. Just click on the console cable, you come to PC, you take RS232, you come to router and you take console port. When you go to the PC, you just click on the PC, then you come to desktop and you come to terminal. You click on terminal, leave everything the way they are and click OK. So we have obtained router's interface on our PC, and when you find something like this, would you like to enter the initial configuration dialog? Just say no. and you hit enter.
Why do you always say no to that command?
Well, would you like to enter the initial configuration dialog?
When it's happening, you say yes.
Well, meaning there are pre-configured things that will come alongside it. So you just need to configure your own things. And this one also comes with a GUI. You know, I want to restart this out just a minute so that we can do it. It will normally comes with a graphical interface, you know, so the practical part of it is very it's not that much intense, because just input IP address, we just do this one graphical, and I think you know what graphical interface means. And so I'll choose another router. I just choose another router and click, and come to CLI. It's still rebooting. I just want to say yes. Would you like to enter basic management setup? Yes. Hostname, you see now how to configure hostname. It's just like a graphical interface. Just write let's say this one is hostname is test router. You see, enable secret. It's the practical part of it. Just much is not much intense, because you are forgetting a lot of commands of how to do it. So enable secret, let's just write Cisco. Enable password, also Cisco. Or they want us to write a different command, Cisco. Virtual terminal password. There's a lot of things. Yeah. Yeah, so it's kind of giving you the command already, so you just input your answer. But you know, when you come here, when we come here, for example, enable config T, that one never give us this one. It didn't give us something like this. For example, when we want to configure hostname, we just write hostname and we write the name. But that one, the hostname was already, the command was already written, and we just have to write the name that is desired. So I don't like using this one, because it should be used by expert, someone who has learned about the commands. But if you not learned the commands, learn it through CLI first, and come back to the configuration dialog. Okay. So the first configuration that you have to do here, we have achieved on how to connect PC to router using console cable. So we need to begin the basic configuration. The basic configuration that we want to start with is hostname. Just click here, click on the PC still. We just say hostname. Let's say this is a test router, test R1. Okay. Then another thing that you want to configure here is line console. Line console, we want to configure password, exec timeout, and login synchronous. Good. So we come here and just say line console 0. Line console 0. The reason why we always write 0, because the line console is only used for one person, because we have only one console port on
a router.
So that's why we use levels. I mean, the first how can I say this? The first level is 0. So 0 represents only one person. But for line VTY, normally you always note that we use from line VTY 0 to 15, because there are 16 interfaces. But for console, we have the one interface, which is represented by line console 0.
For VTY it's 16, right?
Yes, 0 to 15. 0 to 15 is basically 16, because we start counting from 0, 1 to 15. but from line console it's 0, meaning it's only 1. Okay, then line console we use password Cisco, and then I told you that after you include a password, the most important part here is login. Don't ever forget a login command, because if you forget a login command, the user will not be asked password. So the login command is used to authenticate the user. Okay, and also exec timeout and login synchronous. So exec timeout, let's say just 5 minutes. Then login synchronous, and you hit enter. You exit, you come to line VTY 0 to 15. 0 to 15 basically means that there are 16 interfaces, meaning 16 people can log into the switch at the same time. Okay, so line VTY 0 to 15, password Cisco. I normally use Cisco because it's easier to write and to remember. Then login command, then exec timeout. 5 minutes also, and then login synchronous. Hit enter and exit. And then what else? Enable password. Just say enable password to be Cisco. Hit enter, and then encrypting banner messages. Banner message, banner MOTD, 2 characters. Then inside the 2 characters, just say this is test router. So you were asking me, are you there?
Yes.
You were asking something that this one should come first, this one should come first. So the only thing that should come first when you are configuring or the other thing is this one. Okay, so I was saying that the only thing that comes the only thing that precedes the other is the line VTY and line console. For you to configure login synchronous and exec timeout, you must enter line VTY first, because let me just try here. I want to configure exec timeout before I enter the line VTY. I just want to say exec timeout. I'll just try to copy, then I come here and paste. So you see, I find error. Why? Because this thing, this parameter is configured inside this one. So this is the only thing that precedes these two. But for enable password, banner messages, etc., you can do them the way you like, in any order. But remember, for you to configure exec timeout and login synchronous, you must first enter line VTY or line console. Yeah, so that's the only thing that precedes the other. The other thing you can do the way you like them. It's not even a must to start with the host name. You can even write it at the end of the configuration, because the results will be achieved. But for you to write exec timeout and login synchronous, make sure that you first enter the lines. Yeah. Alright, so I'll proceed. Encrypting the password. So encrypting the password that you configure, just say service password encryption. Password encryption. That's one command, and you hit enter. And also the no IP, disable IP domain lookup. Then we prevent brute force attack. So let's do no IP domain lookup, then we do the other two, prevent brute force attack and login delay. So no IP domain lookup, prevent IP domain lookup. So for example, I want to test what we mean by no IP domain lookup. Do right. Remember, this is wrong. This is wrong, but a part of it is right. Do right is right. I mean, right is right, but now double R is wrong. So Cisco iOS, this operating system, is going to say, oh, this command looks familiar. Let me try to check if it's still available in my database. And the process of checking normally takes a lot of time, maybe 30 seconds to 1 minute. You cannot do anything at that point. So we want to disable that kind of domain lookup. Whenever Cisco iOS receives any unfamiliar command, it should immediately discard it. So for example, do right. So this is what we call IP domain lookup. Translating this one. Well, a part of this is looking familiar for Cisco iOS, and that's why it's trying to translate it. And at this point, even if you try to hit enter, nothing happens, and it will disrupt you for around 30 seconds to 1 minute. And now we want to disable it. So there's always a way to cancel it. You just click, you just hit on Control Shift, then then 6. I mean, Control. You just press on Control Shift, then 6. Okay. So we don't want to abort it like that. We want it to abort automatically. So for example, we just say no IP domain lookup. Hit enter. Now let's try to write this command again. Do right. See, now it's gone. We didn't receive this kind of translation for 1 minute. Okay, the other thing that you need to do is to configure brute force attack, preventing brute force attack and login delay if unsuccessful. Okay, so before that, we want to test something. I just say do right to save the configuration. Then I come and say do reload. Do reload. So I'll wait until it reloads, then you're going to test something. Okay, so this is called, you can see this is a banner message, and the first line of protection is line console. So our password was Cisco, but now I want to test something. I want to enter a wrong password. For example, 89. That's wrong. 89 again, wrong. You can see whenever I enter wrong password, an input field is coming on immediately. Enter again immediately. So I want it to delay. I want it to delay for even, let's say, 10 seconds. And whenever I try to do this one 3 times, then it should just lock out so that it doesn't bring the input field. So that's what we call brute force attack and login delay if unsuccessful. For example, whenever I try to log into the switch to the router and I input a wrong password, then it should delay me. It should not come immediately. For example, when I put the wrong password 67, you see it has come immediately so that I can put in again. It has come immediately. So I want it to delay me as a security measure. And also, when I tried 3 times, and all the attempts are unsuccessful, it should just block me so that I cannot find somewhere to input password. So let's go in Cisco enable. So this is enable password. Cisco also config T. The first thing that we're going to do, we're going to configure brute force, preventing brute force attack. How do we do that? We just say login block for block for, let's say block me for 20 seconds, or 20 seconds is not that much good, so let's just say 60 seconds, 1 minute. Whenever I attempt to whenever I attempt to whenever I make 3 attempts within let's say 10 seconds. I want to explain it again. Block me for 60 seconds whenever I make 3 attempts within 10 seconds. So for example, I was trying to log into the switch by inputting wrong password 3 times, and the 3 times are within 10 seconds. So the device will block me for 60 seconds. So I just hit enter. Then login delay. Then how do you configure login delays? Login delay, just say login login delay. Oh, login delay is not just a minute. Line console 0 login delay. Oh, whoa. This command is no longer in use. Exit. Line VTY 0 to 15. Login delay. Login delay 30 seconds. Oh, login delay 30. Okay, so I think the last two, this command it will not work for us at all. Login delay, it will not work because I've tried it, but it's not working. So the next thing that we're going to do is configuring Telnet and SSH. So here, Telnet testing. So we are going to test Telnet here on this route. Remember, whenever we configure just a line VTY, whenever we just configure line VTY, password and everything like this one, we have already configured Telnet. Yeah, it's just a way of configuring Telnet. Configuring line VTY by default is configuring a Telnet. So how can we verify Telnet? I said that let's assume this router here is in server room, and we are using this computer on our desk, and we want to configure this router from this computer. The first thing that we do, we assign this router IP address. We have to assign IP address to this interface here. So we just go to that router, CLI, exit. Okay, which interface is this one? Gig 00 interface, gig 0/0. Then IP address, we just say 192.168.1.1. and then we say subnet mask to be 255. We are going to learn a lot of this in the coming classes. 255.255.0, then no shutdown, because you can see it's red, so we just issue a no shutdown command. Okay, exit and do right. Okay, so we come to this PC here. Remember this was 1.10, and configure the IP address of this router as the default gateway. We're going to learn about this one when in the coming classes. This is just for a demo. 1.1. Then I try to ping default gateway, ping 1.1. So it's pinging. Alright. So I was trying to we need to test. Okay, so we are going to test Telnet from this PC here, from this computer here. We've configured Telnet here by default. We said when you configure a line VTY like this, where is it? Do show start. When you just configure line VTY like this, you've already configured Telnet. So let's verify Telnet on this computer, PC0. I'll come to PC0 and come to CLI and just say Telnet to the IP address of the router 192.168.1.1, and you can see it's asking us password, which was Cisco, and the enable password. We are in router test router 1, also Cisco, from PC0. So this configuring line VTY interfaces and assigning password, login synchronous, and executables is enough for Telnet. So the problem comes when you want to configure SSH. So SSH is a big deal here, and it's one of the most challenging configuration we have. So how do we configure SSH? How do you configure SSH here now? I'll click on the router, and I will highlight the big issue here today is about SSH configuration. SSH. Remember, we have verified that Telnet is working on this PC. We are able to log into the router from this PC. Assume this was our desk. We were somewhere in our desk, and this router here is in server room. So we have achieved the router's interface from this computer on our desk. So let's do another method that is called SSH. The reason why I don't like configuring Telnet is because Telnet has security issues. Telnet is not secure because someone can read all the data we are sending and receiving, because Telnet doesn't support encryption. So that's why Telnet is no longer in use. But for demo purpose or for educational purpose, we need to understand how to configure both of them. But in all the cases that we'll be having, we will be using SSH. Okay. SSH stands for secure. How do we call it? Secure what? SSH. Let me see. SSH stands for secure shell. Yeah. It supports encryption. All the data we send or receive, it's encrypted. Yeah. So SSH is very important. We'll start configuring SSH. How do we configure SSH? Steps. I'll delete this. So step of how to configure SSH. The first thing you do, you make sure that the device has host name. Make sure the device has host name. After ensuring that device has host name, you need to configure username and password. You need to configure username and password on the device. After you configure username and password on the device, then you need to generate crypto keys. Remember I said in SSH it supports encryption, the cryptography, and now you need to generate crypto keys. Generate crypto keys. Generate crypto keys using RSA. RSA is an encryption technique. RSA. It's a symmetric encryption mechanism. So we need to generate crypto keys using encryption mechanism that is called RSA. Then after generating crypto keys, you need to apply them on a VTY interfaces. Okay, so that's all how to configure SSH. The first thing you do, you make sure that device has a hostname. The next thing, you configure a username and a password, because we're going to log into a device using its username and password. The next thing, you have to generate crypto keys using a symmetric encryption algorithm called RSA. You know, there's a lot of encryption algorithm, but in the case of SSH, we normally use RSA, which is something like Riva Shamid, something. It's a name of it was named after someone. Okay, so then you need to apply them on the VTY interface. So I'll go to the router, Cisco, enable config T, enable Cisco config T. So the first thing that I said, you have to ensure that just a minute. You have to ensure that the device has a hostname, and as you can see, we've already configured hostname on the device. Don't leave the device with the default hostname. You have to reconfigure a hostname. The next thing, configure username and password. How do you configure username and password on a device? You just say username Cisco, space, password to be Cisco also. Very easy. Username you specify, password you specify, and you hit enter. That's all. Username is a keyword, and password also is a keyword. So you just have to input what you like as a username and what you like as password here. Okay. Generate crypto keys. How do we generate crypto keys? We just say crypto key generate RSA, and you hit enter. Oh, sorry, I forgot something. Please define a domain name first. The second step was to just hostname and domain name domain name. So I'll begin our process. Make sure that the device has a hostname and a domain name. Remember, in this router we already have hostname, so we need to configure domain name. How do you configure domain name? Just say IP domain name. Let's say cisco.com. Okay, so we've configured hostname and domain name, username and password. Don't forget the three. Hostname first, domain name, then username and password. Although username and password, I've already configured them here, so just make sure you don't forget hostname, domain name, username and password. So we need to generate crypto keys. We just say crypto key generate RSA and hit enter. Then it will ask you how many bits in the modulars. You know, bits basically means the key length. What's the minimum length that you want? You know, in the bracket the minimum is 512. So let's double it, 1024. So that's you know, the longer the key, the harder it becomes to break. So let's use 1024 modulus length. Yeah, and you hit enter. Okay, so apply them on VTY interface. So how do we do that? You just log into VTY interface line VTY 0 to 15. Then remember, we are currently using Telnet, and we were able to log in to the router from this PC here using Telnet. How did we do it? We just issued this command. We just said Telnet to the IP address of the router. So in the case of SSH, we needed to reapply it on the VTY interface. We need to disable Telnet and apply SSH on the VTY interface. For example, if I can just come here again and I just say Telnet to that IP address, you can see it's asking me password Cisco. This is from our PC, this PC here. So we need to disable that Telnet first before SSH can take effect. How do we disable SSH? I mean Telnet. We just say login local and you hit enter. After login local, it will specify that you use the local database. The local database is this one. We've configured username and password. So the local database consists of hostname and password of Cisco. Then after issuing the local data, the login local command, now need to permanently disable Telnet. How do we disable Telnet? Because when we still go back to this PC here and I say end, exit, when I still go to back to this PC and try to issue this command and to enter, you can see it's asking me to enter is Cisco, okay, and password is Cisco. So we are still in router 1 through Telnet command. So let's disable Telnet because Telnet is not secure and activate SSH. Just say transport input SSH and hit enter. Exit and do right. So I'll go back to this PC again and try to Telnet again. Exit. I want to issue this command again. Remember before when I tried to issue this command, we were getting to enter username and password. So let's enter it again. You will see what's happening. You see, connection to that one closed by foreign host because we've disabled Telnet and activated SSH. So let's verify SSH. How do we verify SSH? We want to log into this router from our desk. Remember, this router is in data center, and this is us in the desk. So just click on the computer. How do we log into SSH? Just write SSH, then -L. Then you give the username. The username was Cisco, and IP address of the router 192.168.1.1, and you hit enter. See, SSH is working. Cisco. Enable Cisco. Configured. So as you can see, we can log into the router using SSH and Telnet, and we've already disabled Telnet and activated SSH. And how do we verify SSH? We just say SSH-L. This is not one, L. Then you give the username of the device and IP address of the device, and everything will just work. Okay. So I think SSH has been configured here. SSH has been configured here. So we just need to understand some of the theory behind SSH and Telnet. You see that there are ways to configure networking devices, either locally using line console through the console port and console cable, or remotely using virtual interface, which we use Telnet or SSH protocols. So we see that remote access and configuration, we use Telnet or SSH, and you must have a software which is Telnet or SSH client installed, e.g. PuTTY on the remote device. Then the Telnet or SSH server must be installed and running on the device. So these are just differences between SSH and Telnet. Telnet has port TCP port 23. Telnet has port 23, SSH port 22. All data, including password and username and password that is sent is in clear password, plain text, therefore insecure. But for SSH, all the data are encrypted and therefore secure. So Telnet is rarely used today, and SSH is mostly used today. So these are the steps of how to configure SSH. The first thing, line virtualize that one to that one. This one for configure Telnet, the one that you just be doing. Okay.